Assalamualaikum and salam sejahtera to my lovely doctor. I am Nurul Badrina Aiman and my friend are going to present experiment T3, which is Joule-Thomson effect. So let's start. For the objective, first, to demonstrate the principle of gas cooling by expansion. Second, to demonstrate the throttling process. And third, to demonstrate the Joule-Thomson principle. Next, for the apparatus that we use in this experiment are Joule-Thomson apparatus, temperature probes and digital meter, and CO2 and N2 gas supply. Move to the procedure. In this experiment, it has two parts, which is measurement with CO2 and measurement with N2 gas. So let's start with measurement with CO2 gas. First, all pressure valves are tightly closed and the actual direction to turn the knob is checked. Second, the rubber tubing from the CO2 steel cylinder is connected to the Joule-Thomson apparatus. Third, the cylinder valve and the operating valves is carefully opened by turning the knob clockwise until it stops. The pressure gauge reading are checked. Fourth, the reducing valve is carefully opened and it is adjusted to get the desired gas pressure P1. Maximum pressure P1 of 0.70 bar is started and the value is recorded. When the temperature reading has stabilized, the DT button on the digital meter is pressed and the value is recorded. Pressure P1 is reduced by 0.10 bar using the reducing valves and step 5 is repeated. Step 6 is repeated until P1 equal to 0 bar and data is recorded. For measurement with N2 gas, all procedures are same with CO2. Just change the gas supply with N2 gas and maximum pressure for N2 is 0.80 bar. All the other steps are still the same. And this is all the data that we get in this experiment. So I will pass for more explanation to my friend. Thank you.
Hi and Assalamualaikum. My name is Nuraina Syuhada binti Nurhaizan. So today I'm going to present about data analysis. So before we get started for the data analysis, firstly I calculate the pressure by added the value of gauge pressure that we observe from the experiment with the pressure of atmosphere, and then for the delta T I take the temperature of surrounding and minus it with the temperature of the T1 temperature, so that we got the delta T. From the data we observed that we calculated, we know that the graph that we will do is a linear graph. So we should do the least schematic, and then here that I have calculated. And then after we make the table, we do the count the gradient and the y-intercept C. And then we also calculate the central point. So we got the point is 1.41 and 19.98, and we also get the equation, which is y is equal to negative 0.57x plus 20.78. And from the equation we get the mx minus c, mx plus c, and then we count the y minus mx plus c and y minus mx plus c squared. And then after we calculate the data, and we got the uncertainty of gradient and uncertainty of y-intercept, which is we also calculate the percentage error of gradient that we calculated and the y-intercept that we calculate. Okay, next we go for the nitrogen gas data analysis. So basically, I will repeat the same process of calculation. So firstly, I will count the absolute pressure and the delta T, which is room temperature minus the temperature of obtained in that we observe in the experiment. Okay, and as usual, we know that the graph that we obtain is a linear graph, so that we have to do a least square method, and we make the table, and also we find the gradient of the graph and y-intercept of the graph, and then we find the central point, and then we find the equation of the graph, which is y is equals to 0.4x plus 20.81. So from the equation, we will obtain the table for y minus mx plus c squared. So from the table, we calculate the gradient uncertainties and y-intercept uncertainties, and also from the uncertainties that we obtain, that we calculated, and we find the percentage error for the gradient and y-intercept that we have counted. Here are the both graphs, which is the nitrogen gas delta T versus pressure graph, and carbon dioxide graph, which is delta T versus pressure graph. So from the question 3 that are given, we have to calculate the theoretical value of we have to calculate the coefficient of nitrogen gas and carbon dioxide from the theoretical value that are given. So from that, we have to compare it with our experimental value. So from the calculation that we have made, we get that we have only 28.39% difference for carbon dioxide gas and for 4.17% for nitrogen gas.
Assalamualaikum. Hi, I'm Nur Interbiti Jamil. So for the discussion part, from the experiment, the principle of gas cooling by expansion, the throttling process, and also the Joule-Thomson principle can be demonstrated. Throttling valves are any kind of flow restricting device that cause a significant pressure drop in a fluid. The temperature behavior of a fluid during the throttling process is described by the Joule-Thomson coefficient. When the carbon dioxide and nitrogen passes through the throttling point of the Joule-Thomson apparatus, their pressure drops to atmospheric pressure. Since the pressure is lower, gas cooling by expansion occurs and the temperature of these two gases decreases. From this experiment, positive Joule-Thomson coefficient for both carbon dioxide and nitrogen were obtained. This confirms that both carbon dioxide and nitrogen undergoes temperature drop after throttling process. However, from this experiment, we found that the percentage of deviation of the Joule-Thomson coefficient from the theoretical values is high due to sensitivity temperature measuring device. The temperature measuring device is so sensitive such that the temperature difference obtained was unstable even after being left to stabilize for 1 minute. Besides that, high amount of deviation may also due to leakage of pipes. The gases might leak due to loose connection of pipe with the apparatus or very small holes on the pipes. For the error analysis, firstly, the pressure of the gas is difficult to stabilize, So it is difficult to get the temperature difference from the digital meter because the digital meter was so sensitive. To avoid, make sure the apparatus was not moved or avoid any unnecessary movement to get more accurate values. Secondly, the tube that connect to the Joule-Thomson apparatus is tend to get loose the pressure gas that above 0.7 bar. To avoid, make sure the tube of the apparatus should be connected more tight to prevent the gas get loose.
Okay, so for the conclusion, the coefficient for carbon dioxide gas 0.57 with plus minus 1.07 Kelvin per bar with percentage error 187%, and while coefficient value of nitrogen gas is 0.4 with plus minus 0.05 Kelvin per bar with percentage error 0.38%. And meanwhile for comparison experimental and theoretical value for coefficient value of carbon dioxide is 28.39%, while for nitrogen gas is 4.17%. That's all. Thank you from me.